Hey Room 7, it's Miss Flores here, and I'm here to talk to you about science. So we have started a new chapter called Electricity and Magnetism. So hopefully you're having fun with this. I know for your homework you've been asked to just go ahead and write down the vocab words and definitions, because most of those vocab words and definitions are going to be on your test. Now I'm just going to take it section by section to kind of discuss what we've been reading about and hopefully learning through the videos I've been posting about as well. So starting off in page 92 is where your reading began. It's talking about electricity, and it's having you think about the things that you use in your house that require electricity. You could probably think of a few things like your phone, you could think about your laptop, you could think about if you have an electric toothbrush, you could think about the refrigerator. There's so many different things in our lives that require electricity. So what exactly is electricity? Well, there's a few different types of electricity. So electricity is just a form of energy. It provides a force that makes things move. So even some things might not seem like they have electricity, but really they might have even just a little bit of electricity and you just can't even tell. So the little tiny bits of electricity are called charges. So all matter is made up of small particles. Okay, so those particles are so small that you can't even see them. Even you are made up of small particles. So each particle of matter has electric charges, okay? And each charge is either a positive or a negative charge. And most of the time, matter has the same number of positive charges and negative charges. The charges balance each other and the matter has no charge. And we say it is. So if an object has the same amount of positive and negative charges, it's going to be neutral. Okay, it gave you a few examples of things that are neutral. So it gave you a pole and a towel in your book, and those are going to be neutral. But when you use those two together, such as rubbing the towel on the bowl, okay, you're using the negative charges to move from the glass bowl to the dish towel. Okay, so that means that you're creating that friction between it, that energy, that force, that movement in order to create those charges to flow in. Okay, 94 and 95 talk about static electricity. Now, this is a really fun thing to do if you get a balloon that has helium in it. And so if you've had a birthday recently, you might have one of these around, and you rub it against your hair, and all of a sudden, all of your hair starts to stick out. That is somewhat an example of static electricity. So what is static electricity? Well, static electricity occurs when electrical charges build up on the surface of an object. This happens more often when the air is cold and dry, okay? So the electric charges on an object cause an electric force, and a force, remember, we talked about this in chapter 4, is a push or pull. So sometimes the charges repel, which means they push away from each other, and other times the charges attract. All right, we're moving on to page 96 and 97 and talking about current electricity. Okay, so current electricity, it gives you an example of a cord. And so basically we're talking about how electricity can travel through a cord, okay, because the electricity needs to travel through. So what is current electricity? Okay, current electricity is the continuous movement or flow of negative charges through a material called current electricity. Okay, so energy produced by current electricity can be used in many ways. It can light a light bulb. Okay, so current electricity has way more uses than static electricity does. Current electricity can move through many types of material, okay? So there's a material, and those materials that are considered to let static electricity move through are called conductors. Now, I always think of the conductor on Polar Express. So you know, a conductor on a train, he allows you to come on the train, he allows you to move through the train. And so when I think of the word conductor, I think of a conductor in a train. I don't know. But just think of it this way, that it's allowing things to move through, okay? They are the conductor. Now, a conductor, as far as electricity goes, is a material that allows electricity to flow through it easily. So it's not going to stop the electricity from flowing, it's going to allow it to go through. You also have an insulator. Now, when I think of an insulator, I think of being insulated. So when you have an insulation in your, house or in a building, okay, that means that there's like some type of material inside the walls that allows the building to regulate the temperature. Meaning that if we get really, really hot in Riverside, thank God for these walls and this, roof of insulation, because otherwise we would be burning up in here. And thankfully room 9 is in the shade, so we don't really have that problem. So an insulator is a material that does not allow electricity to flow through it. So think of it this way, it stops, right? Insulator, there's an S, so it stops the electricity from flowing through, okay? And you can think of different examples for an insulator. It gives you wood, glass, rubber, fiberglass, and plastic are all good insulators, meaning that the reason why you can hold your phone cord while it's charging your phone, because the electricity, right, the current electricity is going through to your phone. And the reason why we can hold our cord is because it has the rubber wrapping around it, which is our insulator, so we can't feel that current electricity running through, right? But if you ever touch your cord and it's frayed, so you can see all the different colorful wires in there, which are those are the conductors, and if you accidentally touch it while you're charging your phone, you might feel a little spark, tiny pinch. Don't do it. So we have a conductor and we have an insulator. We also have a resistor, okay? So a resistor reduces the amount of electricity that can flow through a material. It gives you an example of a toaster, okay? It says the heating element inside a toaster is a resistor. So that means that there's like these little heating wires, and you can see that, okay? That kind of helps regulate how much heat to put in the toaster, how much electricity to put in the toaster. Otherwise, if we didn't have those, who knows how much electricity would go through, or maybe none at all, right? Okay, so that allows them to regulate, like a resistor, it regulates the amount of energy or electricity that's going into things such as a toaster, okay? So what is the difference between an insulator and a resistor? Remember, an insulator stops and a resistor reduces. We go on to page 98 and 99, talking about series circuits and parallel circuits. You need two things in order to have electricity flow. Number one, you need a path and you need a power source, okay? So electricity cannot flow unless it has a path or a power source. So in this instance, in your book on page 98, your power source would be your battery and the path would be those wires. So what is a circuit? A circuit is an unbroken path for negative charges to flow through. So a circuit is an unbroken path, meaning that it can't be disconnected. It has to be intact all the way through, from your power source to your bulb or to another power source. It cannot be disconnected. It needs to go all the way through, okay? And the negative charges need to flow through the circuits. We have a parallel circuit and we have a series circuit. So let's talk about parallel circuits. A parallel circuit has more than one path for the electricity, meaning that you could have one cord where the electricity flows through, and then you could have another cord that's attached where electricity flows through, and another cord, okay? In your book on page 99, it gives you an example of the parallel cords and how there's multiple routes, multiple cords, multiple paths that the electricity can flow through. So it's parallel. Remember in math, we talk about parallel like this, right? There needs to be at least two lines and parallels. Think of it that way. There needs to be at least two pathways for a parallel circuit. All right, and what is a series circuit? So a series circuit has only one path. All right, I'm gonna come back with another video talking about the rest of the chapter. So hopefully this was helpful. If you don't know what to study, go back and look at all the different words that I talked about in this video, and that will definitely help you be prepared. If you've read and you've answered and you wrote down all of your vocab words and definitions, you can use your notes for our test on Friday, and let me know if you have any questions. All right, hopefully you're finding magnets around your house and seeing what kind of static electricity you can create, and let me know if you have any questions. The choice boards that you're doing, hopefully those are fun activities to kind of like implement what you're learning around your household, and I can't wait to see what you guys come up with and read what you guys do. Hopefully that's fun for you. All right, we'll see you guys next time. Bye.